What we're going to do here is we're going to look at adding and subtracting decimals. Now what's nice is that the format of the decimal keeps, we can really repeat everything we did with whole numbers. So if we look at addition or subtraction, let's start with subtraction. I'll use the example from the slides. So if I have 85 and I take away 13.26 or 13 and 26 hundredths. So I'm doing a subtraction. I have some quantity and I'm taking some measure through. What we want to do is we line it up vertically. With the decimal point as our guide. So this number goes on top, and 85 kind of has a hidden decimal point. This is the whole number to the left of the decimal point, but it would be there. And so I line up the decimal points, and I'll use the subtraction. Now what's nice is this has 0 tenths and 0 hundredths. So I add zeros to the right where needed. And at this point, we can do exactly what we did with whole numbers. So 6 from 0, well, that doesn't work, so I'm going to have to borrow 1 from here. But that's already taken, so I'm going to have to borrow 1 from here. And so borrowing 1 from there makes that a 10, but I borrowed 1 over, so that becomes a 9. And the 1 I borrowed from there makes that a 10. So 6 from 10 is 4. 2 from 9 is 7. 3 from 4 is 1. And 1 from 8 is 7. And so 85 minus 13 and 26 hundredths is 71 and 74 hundredths. Well, let's check. Let's do addition. So if we want to check this, we can add these two things to get back to this. So again, I'll line up my decimal points vertically, and we'll do an addition. So 4 plus 6 is 10, so I'll write the 0, and I'll bring over my 1. 1 plus 7 is 8, plus 2 is 10, so I'll carry my 1. That gives me 5 and 8. The 7 plus 1. And so I did get back up there. So we really get what we had with whole numbers. And everything's done with the lining up of the decimal point. All right, let's look at a large addition. All right, we can do multiple additions, so let's do one. So I don't know, I have some different measurements, and I want to see the total that I get from these measurements. So I'm going to line up top to bottom, and I think I'll start with my biggest number upstairs. Not upstairs like a fraction, but at the top of my addition list. And now I'm going to line up the decimal point. And I'll do my last number here. So again, my goal is to line up the decimal point. And it looks like I need an extra 0 at the end of this one so that I filled the space. And so now I use the algorithm we used for whole numbers. I come down the thousandths place, and 4 plus 7 is 11, so I'll carry my 1. 1 plus 4 is 5, plus 8 is 13. And so I will carry my 1 Just double checking my numbers. Ah, see what I did? I wrote a 4, not a 3. I knew my numbers were off. Well, let's fix that. Let's turn this to a 3. Always double check your writing. I do this occasionally. So let's re-add up this column. Let's come over here. Let's clean this up a bit. If you have me in class, one of the things I do is I do my things without my notes in front of me, so that if I make a mistake, I can show how we fix them. And I made a copying error, and I noticed it when I looked back up. Always double check your stuff. And mistakes do happen. Fixing them is part of what we have to do in mathematics. Trust me, my live lectures are fun, in the fact that I will, struggle, because I don't have notes in front of me. I don't know what the right answer is, and we'll double check the math. And, this isn't live, but I still like occasionally making a natural mistake to show people how to fix it. Because errors do happen, and learning from them is our best way out of them. So I fixed my copy error, and I noticed it when I was looking up, because that column didn't look right, because I'd done the problem before I knew what the number should be. And I was like, where did I go wrong? I was like, oh yeah, I miscopied. So 0 plus 4 plus 7 is 11, carry my 1. 1 plus 3 is 4, plus 8 is 12, again, carry my 1. 1 plus 2 is 3, and 5 is 8. 6 plus 6 is 12, plus 1 is 13, carry my 1. 6, 8, and the 7 has nothing below it. So my sum of all of these measures is 783 and 821 hundredths. Let's just do some more, and hopefully I will keep my copying errors to a minimum. So I have 19 plus 26 and 72 thousandths. So I'm going to line these up. I actually like writing the larger thing that I start with. Not the larger number, but the thing with the most places up top first. Again, I want to line up the decimal point. 119 doesn't have one, but there's one implied, because whole numbers are to the left of it. So I'll put that there. And I'll add zeros to fill it out. Sorry, for some reason the fan on my computer is going off a lot right now. Add here, 2 plus 0 is 2. 7 plus 0 is 7. 0 plus 0. And then 6 plus 9 is 15. Carry my 1. 3, 4. Now notice, when I have a whole number here with nothing towards it, I'm going to get all zeros here. So this part will come back naturally. And that's just a pattern we can notice when we do these. Now, if we have two signs, a sign difference, we can use our sign rules. But we have to be careful, because the fractions we're taking in here will cause this to come. We really want to kind of write it as a subtraction. So if I take 7.12, or 7 and 12 hundredths, plus a negative 9 and 92 hundredths. Now, we have two different signs, so what we're going to do is we're going to take the larger of the two numbers and write it first, and subtract the smaller of the two numbers. So 2 minus 2 is 0. 9 minus 1 is 8. And 9 minus 7 is 2. But our larger number was negative. So this answer to this is negative 2.80. And we don't need to write the 0 on the end. So this is negative 2 and 8 tenths. All right, let's look at a subtraction of decimals. So if I have 56 and I say 56, but I write 52. So if I have 56 and 21 hundredths minus 5 and 9 tenths, well, this is a straight subtraction. So the larger number goes up top, or the first number goes up top, the first number, not the larger, minus 5.9. I'll get my extra 0 to fill the place, and 1 minus 0 is 1. I have to borrow 1 to do this subtraction, so 12 minus 9 is 3. Keep my decimal point lined up. 5 minus 5 is 0, and there's a 0 kind of hiding here. We get 50 and 31 hundredths. Let's do another one. 28 minus 3.3. So again, this is going to go on top. And this is going to go down below, lining up the decimal points. Well, I'll have to put a decimal point there and write 3.3. Because 28 is a whole number, so it's to the left of the decimal point. We can line up decimal points. I'm going to have to put a 0 in to fill the space. Now 3 can't go from 0, so I'm going to have to borrow 1 again. And 10 minus 3 is 7. 7 minus 3 is 4. And I get 24.7. Let's look at a subtraction with signs and decimals. So if I have negative 5.4 and I'm taking away 9.6. Well, there's two ways to think of this. I like thinking of subtraction as the addition of the opposite. Because now I have my addition rule and my signs are the same. So with my signs being the same, I'll add my two numbers. So 4 plus 6 is 10, carry my 1, and that's going to give me 15. But because my signs were the same, this gets the same sign. So what's nice about thinking of subtraction as addition of the opposite is we can deal with our sign rules as we've used them before when we learned integers. Let's do another subtraction here. Minus, whoops, let me change colors since I don't want to confuse the problems. I've been trying to color code them. So I have negative 1.05, and I'm going to subtract from it negative 7.23. Well, again, we'll think of it as an addition of the opposite. So the opposite of a negative number is its positive number. And now I'm adding with two different signs. So I'll take the larger, and I'll subtract from it the smaller number. So I have to borrow 1 to make the 3 work. So that's going to become a 1. 13 minus 5 is 8. 1 minus 0 leaves me 1. And 7 minus 1 is 6. My larger number was positive, so this is a positive answer. So see how all our rules are coming back to us? All right. And decimals can fall into algebraic expressions also. Let me start a new page here. And so if I have an algebraic expression and I want decimals to represent the variables in the expression, I can replace these just like we did before. And so decimals really are numbers that have a fractional representation that follow all the rules that we had before. They're just a special way of writing some specific fractions. So 5 plus 8 is 13, carry my 1. 5 plus 2 plus 1 is 8. And lining up the decimal point, my answer is 8.3. Well, this can even happen in expressions that we don't have the variables for. So if I have negative 4.3, or negative 4 and 3/10 times y, plus 7 and 8/10 minus 20.1 y plus 14.6. We have to do the same thing. We have to gather like terms. And so my like terms are my y's and my constants. So I'll gather my y's together. I have negative 4.3y and negative 20.1y. So they have the same sign, which is negative. So having the same sign, I add them and keep the sign. So altogether, I have negative 24.4 y's. And now I'll look at my constants. So I have 14.6 and 7.8, both positive. So 6 plus 8 is 4. Keep my decimal points lined up, carry my 1. 5 plus 7 is 12, carry my 1. And so when I combine like terms, the constants come together. Constants come together to give me the total constants, and the variables come together to count up how much of the variables I have. Well, where we use decimals a lot in our day-to-day life is money. And so we'll find that we want to find the total. So that's telling me I'm probably going to add monthly cost. Of owning and operating a car. Given that the monthly car payment is $563.52. Insurance per month is $52.68. And the average gasoline cost is $127.50. So if these are my monthly expenses for owning this automobile, I'll grab all the costs together. And I'll add by columns. Sorry, my 6 looked a little ghostly there. And so 2 plus 8 plus 0 is 10. Carry my 1. 6, 12, 17. Making sure all my numbers are right here. 2 plus 8 is 0. Carry my 1. 6, 12, 17, carry my 1, and then 1 plus 3 is 4, 6 plus 7 is 13, carry my 1, And there's my sickly 6 there. So that's 7, 12, 14. Carry my 1. And so I get $743.70 per month. Now, a thing we could do is we could kind of estimate this. And there's a couple different ways to estimate. What we tend to do when estimating is to just look at the last digits on the left. So this is 563. Well, I'll round to the hundredths place. So that's 600. This is 52 and 68ths. Well, the last digit is in the tenths place, so I'll round that. And if I look at the 2, that rounds to 50. And then in 127 is a hundredths place, so I'll round to the hundredths place, that's 100. And if I estimate that, it's around $750, which is close. It's a good estimate. I don't like rounding down with money. I always try to round up. That way I don't underestimate my costs. All right, and so this is adding and subtracting decimals. And we should note that it is the same as what we did for whole numbers, but the decimal place now is the thing we line up. We line up the decimal place, and that keeps our numbers together for us. All right, we will continue our study of decimals in the next video.